Hello. Welcome to my Atlant's backend engineering interns project presentation. So, for the project, I worked on Evently, which was the second project in the project list. So, it's an event management system. So, I will be quickly going through all the features and the high-level system design and the ER diagram. I will quickly going through that, and so that we can go towards the actual implementation and the working of the API. What's the key features? So first is event management. You can create, update, and delete the events and all this stuff. You can create the bookings. You can, get analytics and all that stuff. User authentication. We did that using JWT, stateless authentication. It is differentiated using two roles, which is admin and the user. Then we have the seat level booking system. So every event has a fixed number of seats, which can be increased using the update route, but the user gets to know about the seats available. Okay, so the first seat is booked, second seat is booked. Okay, let's just book the third seat, right? So the user can do that, right? Waitlist management. So let's just say all the seats are booked in the what you can say the event, right? In that case, what the user can do is he can enter a wait list, right? And how the wait list is implemented. So I was going through the different things that Redis provides, and basically Redis like provides a lot of data structures that can be accessed, which are being stored on the main memory. And one of the data structure I found out was sorted set, right? So I am using sorted set as a priority queue, right? Where the I'm picking the most recent um, entry that was pushed to the waitlist. So whenever seed is cancelled, so what we will do is we will look at the sorted set. We will talk to the sorted set and ask for the uh, latest entry that was pushed to the sorted set and get the entry and notify the user. Okay, so this event seat is empty and you can book the seats. So the number of entries we take out can be configured in the implementation. So it's pretty flexible, right? Then I also wanted to try out Nginx with rate limiting because we had studied rate limiting in computer networking, I guess, and I never actually implemented it. So I went through the documentation and I found out it implements something called as a leaky bucket algorithm, right? So like in the Nginx, we implemented that, and Nginx works as a reverse proxy as well as a rate limiter, right? Then we also implemented caching. So caching was implemented as a read-through cache. So here's a read-through Redis cache. The replicas that are running using Docker Swarm will communicate with the Redis server. And if the cache hit is done, if the cache is present, then we will simply just return the cache, right? Otherwise, we have to populate the Redis, right? So what we will do is we will send a database call. It will send the data back. It will populate Redis as well as it will send the data to the replicas, which will be further forwarded to the client. Right? It's pretty simple. Then we have analytics dashboard, obviously for analytics. Uh, then we have async architecture. So since we are using fast API, it's inherently async. And the thing is, if you have a sync framework, you cannot use blocking calls, right? You cannot use uh, a synchronous SQL engine. You need an asynchronous SQL engine. So this is why I went with async SQL Alchemy. There were a lot of issues. Like one of the issues that I faced was is that the async version cannot use things like lazy loading, which is the core feature of SQL Alchemy. So that is one of the issues. Then the whole thing is Docker ready. So here's the Docker Compose file. Uh, Here's the Docker Compose file. We have the ash, we have the app, we have the replicas, we have the database, we have the cache, we have the Nginx, we have the adminer to access the database with UI. So uh, it's pretty cool. Then we also use Docker Swarm. So whenever we define replicas, so it uses the latest version of Docker Swarm. So Docker Swarm kind of creates a lot of replicas, adds a service mesh as well as a load balancing service, load balancer, and all the things are forwarded to this, and this is divided among the replicas. So yeah, so like in the future you can definitely, since this is an stateless application, you can definitely utilize some other horizontal scaling practice, something like a Kubernetes or something like that, right? Other things. So we can definitely port it to different architectures, right? Then this is some quick trade-offs we had with the project. This is the technologies we used. Then this is the ER diagram. User has one to many mapping with events. User Admin user can create events, and events has one to many mapping with seats, and seats has one to one mapping with bookings, right? And bookings take up status. Okay, so I believe the whole database model can definitely be optimized because like I feel like I'm not so experienced with data modeling and things. So I believe this can definitely be optimized, right? Yeah, so this was documentation which is present on my GitHub. Okay, so I guess it's running, right? Yeah, it's running. All right. So we have our instance of Nginx, three instances of our replicated, what do you say, the application, the Postgres, Redis, and the Adminer. We're quickly going through this is the docs, right? This is being accessed, OpenAI API docs is being accessed through localhost, which is being forwarded from Nginx, right? So we will be quickly going through the OpenAPI docs. Okay, so let's start by creating an admin user. Uh, what should I name this? Test at gmail.com. Test and let's create this as an admin. Okay, we created this. Let's log in. Test gmail.com and test. Cool. Right. Now we have been logged in and the JWT token will be passed with all the requests. That's a really great thing about our OpenAPI. This where you are. Okay, so we have been logged in. Cool. So let's just create a new event. Let's create an event one, uh, value one, description. Okay, let's leave that as string and let's capacity as let's just say 3. Good. Invalid requirements. It's going to change this. Right, it's just saying invalid requirements. Did I miss something? Okay, so the reason it was showing the invalid requirement is because we have start time and end time as same, right? So I need to change this. Okay, so let's change the month. And let's create this. Okay, so we created this event. Let's create more events. Let's give it event 2 on same venue. Cool. Event 2 created. Let's create event 3 on same venue. Created. Let's create event this on venue 2. Ensure that event is set. Event 3 was created. Let us check in the, yeah, it's already created. So we need event 4. Let's create it on venue 2. Cool. And let's have a look. So the listing thing works using the I like uh, query. So I can give something like event and it will give uh, all the wildcard matching for event. If I give specific name like event one, it will give me exact uh, event one, right? That's cool. Let's just, we can also fetch by venue. So venue one. Okay, so venue one is for these three, which were created with their capacities. And venue two, if I just write venue, it will do the wildcard matching and give us all the events with the prefix as venue. Otherwise, venue two would give us a single one. Similarly, you can do it with from date and date. You can edit this, set offset, all the stuff. Then you can delete the event. You can get a specific event. Let's get one. Yeah, so you can get the specific event, right? All right. You can update the events. You can update the capacity. You can increase the capacity. You can change this. You can change the start date, end date, and all those things. So let's do one thing. Let's get the bookings by the current user, right? We haven't done a booking, right? We haven't done a booking, right? So let's just create some bookings and see the change. So I want event one, and we have also the seat routes, right? Where are the seat routes? We can list the different seats that are available for the each of the events. I need to find that. Date is done. List event route is fine. Get event route, okay. Yeah, list seats route. Event ID one. So for the event ID one, we have seat number one, which is available, seat number two, which is available, seat number three, which is available. Cool. Let's let's book these seats, right? Seat number one, booked, right? So seat number one is booked for our user, uh, current user. Let's book seat number two. Book. Let's try to book the seat number two again. Seat is already booked. You cannot do that, right? It's pretty simple. Let's book seat number three. Book. Let's try to book seat number four. That does not exist, right? It won't be booked. Let's just say I change my mind and I want to increase the number of seats for my event, right? So I will simply go here, update. If I keep it as one, it will simply fail because you cannot decrease the number of seats on their book, right? So just make it four. We added one more seat, right? And then let's book that seat also. So initially it was giving a seat capacity full. Now we can book the seat. Booked. Right, cool. Now we will go to the list seats route and check what it's giving us. All right. So for initially we had three seats and we booked all of those. Then we updated the event. We incremented one more seat and we also booked that. Right. This is cool. Uh, so let's get the bookings by the user. So user has booked four seats. Right. Cool. All right. So let's say the user changed his mind. Right. He said, all right, I booked four seats, but only needed like three, right? In that case, he can cancel a seat. So let's just say the user does not want the seat with seat number two. So what he will do is he will take the booking ID and send it to be cancelled. Cancelled, right? This should be cancelled now. Then we go here, cancelled, right? Booking number two, seat number two is cancelled, which means that the seat should be available to be booked, right? Let's go to the seat events route. See, seat number two is now available to be booked, which means that the user cancelled his booking uh, and user can the other user can now book this specific seat because it is not available, right? Now we check again, right? So cancel, cool. Now the user changes mind, he wants to book again. So what he will do is he will simply book this seat again. It was seat number two, right? It was seat number two. Cool. So user can book the seat again. Sorry, one, right? Booked, right? Now let's go to the seat ends route. It should be booked now. Booked. Right. And also, we also I stumbled across a really great video by Hussein Nasir. He's like one of my favorite YouTubers for backend architecture and engineering. And he had this exact video about how to avoid double booking and race condition in online web applications. So he basically mentioned about something like a pessimistic locking that can be used to avoid double booking, and I implemented that. So double booking cannot be done because whenever we
What?
try to update the specific or do a booking or transaction, we first pessimistically lock the specific seat, right? So the double booking or race condition is not possible. Yeah, he has a really great video about this. So I got to know about that. Okay, so we have booked the seat. If we go to the user's history, then user booked, 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 cancelled, right? He cancelled seat number two, but he booked again, right? So this is a cool thing. We keep the history of all that stuff. So now the thing is, all the seats are booked. We cannot book more seats, right? If I go there, if I write seat number five, it won't be booked because capacity is full. What we can do now is we can make the user enter a wait list, right? These are all the analytics you can do, uh, execute. So most popular events, yeah, event one is the most popular with 100% utilization because they booked all the seats, status full. Uh, yeah, other are not booked, so they have zero utilization, zero booked seats. You can also get the matrix about different things. So let's just try the waitlist thing. Okay, so we will say I need a wait list for event one. So if there are seats remaining, it will simply return, sir, you have your seats remaining. You can definitely book that. Don't enter the wait list. Add it to wait list. Boom. Now you have added to wait list. Right. I didn't implement the waiting service. I was initially going to implement the notification service using a mail gun. So I would send the mail to the user by fetching the user ID and all the things from the mail list. Sorry, from the waiting list. But I did not implement that because like I had some confusion, so I like skipped that part. Right. So let's just say user thinks, all right, let us cancel the booking third. We cancelled this, right? Which means we had something in the wait list. We canceled one of the tickets from event one. Then something should have happened, I guess, in the logs, right? It is happening. So if you see this, which means that capacity for yeah. So when when the user cancelled his booking, so what we did was we picked the latest booking from the waiting list, we popped it, and we call this dummy function. So this dummy function has basically a print statement. I did not create the notification service called notification service and a data structure that was stored inside Redis. So it was stored inside Redis as a string, JSON string. We you know we deserialized the string and created a Python object. And you can see ID, name, event one, venue one, description, start time, end time. It shows the event detail created by third, wait list. So which user put the his request in the wait list? User number three, wait list, user email. This is the email, and you can use this to send it to the notification service and do the thing. So this was kind of a really great project I got to work on. There are a lot of different things I could showcase, but I guess I have already taken a lot of time. So I wanted to deploy this on a backend. Sorry, I deploy this on. So I wanted to deploy this on cloud, but there are different components, right? There are a lot of components, and I cannot deploy it. I have deployed services for us early age AI startup on their AWS. I created Lambda services for them. I do have uh, experience deploying Kubernetes clustered on Oracle with Oracle Kubernetes engine. Uh, but the thing is, they were the accounts which were given by the organization itself, right? So I could deploy that. But this architecture is like quite complex, and I would require credits to deploy this. So I didn't actually deploy this. So like one of the thing I can do is I can deploy. I will have it deployed here, and I can expose this using a Cloudflare tunnel. So I can create an ngrok tunnel or Cloudflare tunnel, and I can expose this to a static domain name and if you guys want to access that, you can do that. Otherwise, you can just git clone this for the documentation and get it running on your local PC, which is a simple Docker compose up dash dash build command. So it's pretty simple. So yeah, thank you for my giving me this opportunity to create this amazing project. Um, and this was a really great thing to work on. Uh, uh, and one of the issue is like I really wanted to be the whole video recording on time, but um, I guess I wanted to talk about a lot of things, so I'm really sorry for that. Also, I guess this video was recorded in multiple different smaller takes, like right. So my screen recorder doesn't allow to record more than I guess 7 to 10 minutes, so I have to like bunch these up, right? Anyways, thanks a lot for this opportunity. I'm really grateful. Thank you. Bye.